In this video, let us look at how to draw the dot and cross diagram for ionic compounds. An ionic compound is usually formed between a metal and a non-metal. Metal atoms have fewer valence electrons and tend to lose electrons to form cations, while non-metal atoms have more valence electrons and tend to gain electrons to form anions. Let us look at some examples. A sodium atom has 11 electrons and its electronic configuration is 2.8.1. There is one valence electron, which is easily lost to form a sodium cation. In the process of losing the electron, the sodium atom achieves a fully filled valence shell, or what we call the stable noble gas configuration. This is how we write the ionic equation. We start on the left, the sodium atom. It becomes a sodium ion, and there is one electron that is being lost. Let us look at another example. This is the calcium atom. It has two valence electrons. These two electrons are easily lost to form the calcium ion, which also has the stable noble gas configuration. Again, to write the ionic equation, calcium atom on the left forming calcium ion on the right, and it leaves us with two electrons that are lost. Remember that in an ionic equation, the charges must balance on both sides, meaning that on the left side there is no charge. On the right side there is 2 plus and 2 minus, which cancel out, making it 0. The same goes for anions. Let's look at the chlorine atom. Chlorine is in group 7. It has 7 valence electrons. There is a tendency for chlorine to gain 1 electron to form a chloride ion, and this chloride ion has a fully filled valence shell. Again, the half equation or the ionic equation, we have the chlorine atom, which gains 1 electron, that's why plus E, to form the chloride ion. Another example, let's look at the oxygen atom. Oxygen is in group 6, period 2, 6 valence electrons. It easily gains 2 electrons to form the oxide ion, which has a fully filled valence shell again. Here is the ionic equation. So we have the oxygen atom gaining 2 electrons to form the oxide ion with a negative 2 charge. Now let us look at how to draw dot and cross diagram. Over here we are drawing sodium chloride. So the sodium chloride is a compound which consists of sodium ion and chloride ion. So let's start with sodium. Sodium is in period 3. It has 3 shells and the electronic configuration is 2, 8, 1. Chlorine, electronic configuration is 2, 8, 7. Sodium is a metal. Chlorine is a non-metal. Metals and non-metals tend to form ionic compounds. So sodium can lose its valence electron to form a sodium ion, while on the other hand, chlorine will want to gain an electron to form the chloride ion. Now we have a cation and an anion, and you know that opposite charges would attract, and the electrostatic forces of attraction between the sodium ion and the chloride ion is what holds everything together in the lattice structure. So typically we will show all the electrons unless it's otherwise stated. Here is another example. Now we have an element X which is in period 3, group 2 of the periodic table, and we are asked to draw the dot and cross diagram of XCl2. Given this information, we can identify that element X is magnesium. So period 3 means it has 3 shells. So the first shell holds 2 electrons followed by 8. And group 2 means that the outermost shell has 2 valence electrons. Chlorine is in group 7. So again, let's put in the electrons for chlorine. X is a metal. Chlorine is a non-metal, so therefore the compound form is ionic. Element X can lose 2 valence electrons to form a cation with a 2+ charge. Chlorine, on the other hand, would want to gain only 1 electron to form the chloride ion. This leaves us with 1 additional electron here to be gained, and we can get another chlorine atom to come in, which can gain the remaining electron. Now we see that X loses 2 electrons, and each of these chlorine atom gains 1 electron. To save time, we can write it in this way, where the 2 denotes that there are 2 chloride ions for every X ion. One more example, sodium sulfide. Starting with sodium, let's put in the electrons, 2, 8, 1. Sodium has 1 valence electron. Sulfur has 6 valence electrons. Sodium is a metal, sulfur is a non-metal. Therefore, the compound form will be ionic. Sodium can lose its valence electron to form a sodium ion. Sulfur can gain an electron, but you notice that by gaining only 1 electron, it is still short of 1 for a complete valence shell. So we can get 1 more sodium atom to come in. The second sodium atom can now lose its electron to form another sodium ion, and this electron here can be gained by the sulfur atom to form a sulfide ion. Together, we can combine everything to form sodium sulfide. Remember, in drawing dot and cross diagrams for ionic compounds, pay attention that you need to have the coefficients if necessary, square brackets, and the charges must be correct. That's all for this lesson. Have a go at trying to draw the dot and cross diagrams for the following ionic compounds.